atmospheric pressure. As we have already done in our lectures 1, 2 and 3 about force, pressure, liquid pressure, atmospheric pressure, this is more about atmospheric pressure. As we know, the envelope of air surrounding Earth is called atmosphere. This atmosphere exerts a lot of pressure on ourselves from all the directions. This is called as atmospheric pressure. Now the question arises why we are not able to feel this atmospheric pressure. We are not able to feel this atmospheric pressure though it is enormous, about 1.1 into 10 power 5 Newton per meter square. But we are not able to feel this because this pressure is available everywhere on Earth. Wherever you go, there will be atmospheric pressure. Second, there is blood in our body which is pumped by heart. This heart, when it pumps the blood pressure is created. This blood pressure is almost equal to the atmospheric pressure, and so we are not able to feel this pressure. Those people have high and low blood pressure problems, they feel a little bit pressure they can feel. The atmospheric pressure as you go on higher altitudes, the or very high altitudes, that is while mountaineering at certain heights, the nose starts bleeding, the ears starts popping. So these things happen at higher altitudes because at higher altitudes the pressure is low. The depth of the air column is low there, so the pressure is low. So atmospheric pressure decreases as we go on higher altitudes, and so inside pressure is high, and so the nose starts bleeding. Even if the food is cooked in open containers, not in pressure cookers, in open containers, it is difficult to cook food in open containers on higher altitudes because at higher altitudes the atmospheric pressure outside is low, and so it is difficult to cook food at higher altitudes in open containers. The weight of an air column of the height of the atmosphere area 10 into 10 centimeters square is as large as 1000 kg. That means on an area of 10 into 10, that is 100 centimeters square, the atmospheric pressure is about 1000 kg or 1000 kg. Now you see, this is here 10 by 10, the diagram is being shown 10 by 10 centimeters square. This is a big container or a cuboidal box. The base is 10 by 10, and above this there is air column. So this air column is exerting a pressure of about 1000 kg. Uh, Next is here, you see rubber suckers. This is a rubber sucker. So these type of suckers are there, and so they are often used below your laptops and below certain electronic gadgets, electronic containers, below your mixies, grinders, and they are applied. So they suck the air, and a vacuum is created, and the object is being connected easily to the ground. And when you use it, it doesn't move. Another, you see here there's a diagram and some horses are pulling a certain vacuum. This at the center you see there's a ball like structure, and this ball like structure is vacuum. It is made up of two parts. Two cups are there, and both in between them a vacuum is created, and both are being pulled by horses from both the sides, and a lot of force is being applied, but these two containers doesn't come apart. That means atmospheric pressure is quite high. So this shows that how large is atmospheric pressure. Atmospheric pressure is measured by an instrument that is called as barometer. There are two types of barometers. One is liquid barometers, another is aneroid barometers. Aneroid barometers do not contain any liquid, so that's why they are called as aneroid. And then you have effects of pressure. The first effect of pressure is that as we go on higher altitudes, then your ears starts popping, the nose starts bleeding. This is because at higher altitudes, I've already told you, the pressure is low, so inside pressure is higher, and so the nose starts bleeding and ears starts popping. The atmospheric uh, the astronauts wear special prepared suits, as when the astronauts go in space, the pressure is quite low there because there's no atmosphere in space. So astronauts wear special suits because inside pressure is quite high and outside pressure is zero, or sometimes when they go on planets, they go on a moon, that is your satellite. So the pressure there is low, that is atmospheric pressure, atmosphere is low there, so atmospheric pressure is there, the atmospheric pressure is quite low. So because the moon has very less atmosphere, sometimes no atmosphere on moon, so there the pressure inside, blood pressure is quite higher, and outside the pressure is quite low or almost zero. So the astronauts have to wear some special kinds of suits to maintain the pressure inside, otherwise they will collapse there. And the last point is mountaineers, they counter a lot of problems when they go on higher altitudes. For example, as I told you, nose bleeding and so on. The forces of atmospheric pressure. The atmospheric pressure exerted by atmosphere is uh, very huge. That is why the atmospheric pressure is quite huge. So the reason is that the air column is quite high, though, and so that is the value of atmospheric pressure is about 1.1 into 10 power 5 Newton per meter square. That is approximately on an area of 100 centimeters square. The pressure is equivalent to a mass of an object which is 1000 kg or 10,000 Newton. These are the exercises, students. These are the the points about the content. They are written. Small brief questions are also there, and small brief descriptions are also there. So definitions are there. You round up here properly with these small definitions. Go through them nicely, read them, and next is the exercises. Here, question answers have to be done, and some of the answers are written here. You can read them carefully, and you have to do all these exercises in your fair notebook. If you are not having a fair notebook, then you do them on the plain sheets of register, rough register pages. You have registers, old registers, you can take out pages from them and punch them and do these exercises. Uh, if the visibility is poor, I will be posting them on YouTube also. Your this I'll be posting them on the WhatsApp group. Okay, so YouTube, it's already available, and I will be posting them on WhatsApp group, from where you can copy and see the questions and answers and exercises also. Do all the exercises. This is your homework, and we'll see the next chapter. We'll study the next chapter in next week. Thank you.